Welcome to this lesson on measuring and reading DC and AC voltage using an analog multimeter. In this session, you'll learn the essential steps for accurately measuring voltage, both direct current and alternating current, using an analog multimeter. Whether you're dealing with a simple battery or household electrical outlets, understanding how to use your multimeter properly is crucial for ensuring safety and accuracy in your readings. Let's begin with DC voltage. Before we start measuring, it's important to correctly set up your analog multimeter. First, turn the range selector switch to the DCV setting. Turn the range selector switch to the DCV setting. Look for the symbol DCV or a straight line above a dashed line, indicating direct current voltage. Let's move on to selecting the appropriate range. When measuring voltage, it's always wise to start with a range higher than what you expect to measure. For example, if you're measuring a 12V battery, select the 50V range. Safety tips. If you're unsure of the voltage you're measuring, begin with the higher range to prevent damage to the multimeter. Let's practice by measuring this brand new 9V battery. Since we're dealing with a 9V battery, we'll select the 10V range. The range is set to 10V, meaning the maximum voltage we can measure is only 10V. It's important to note that unlike resistance measurements, where the range must be multiplied, voltage readings are straightforward. Next, let's connect the probes. The red probe should be connected to the positive terminal and the black probe to the negative terminal of the battery or component you're measuring. Identifying the positive side is usually straightforward. Look for the plus symbol. Some batteries use color, red to indicate positive and black or white for negative. Now, it's time to read the voltage. When reading DC voltage, you'll use a specific scale on your multimeter. But how do we read the DC voltage? When reading voltage, whether DC or AC, we use this scale. The scale below is specifically for AC voltage that is less than 10 volts. If you notice, it displays only the ranges 250, 50, and 10. But what about the ranges for 1000, 25, 0.25, and 0.1? Additionally, it only shows 6 values for each range. For the 250 range, it displays 0, 50, 100, 150, 200, and 250. For the 50V range, the values are 0, 10, 20, 30, 40, and 50. For the 10V range, it shows 0, 2, 4, 6, 8, and 10. So, how do you determine the value of each bar? It's simple, the scale has 50 divisions. You just need to divide the range by 50. For example, for the 1000 range, divide by 50, and the value of each bar equals 20 volts. For the 250 range, divide by 50, and each bar equals 5 volts, and so on. Returning to the battery reading. The range is set to 10 volts, meaning the value of each bar is 0.2 volts. Starting from 8 volts, the values progress as 8.2, 8.4, 8.6, 8.8, 9, 9.2, 9.4, and 9.6. Therefore, the battery's voltage is 9.6 volts. Why is the reading 9.6 volts when the battery is a 9V battery? This is because a fully charged 9V battery can read slightly higher, such as 9.5V or even up to 9.6V. If the battery is depleted, the reading will be lower than 9V, indicating that it may need to be replaced. Now that we've covered the basics, let's apply this knowledge in a practical scenario. Imagine you have a combination circuit with 3 bulbs, each with different resistance values. Your task is to measure the voltage drop across each bulb. First, ensure that your multimeter is set to DCV mode, just as we did earlier. Let's move on to selecting the appropriate range. Quick question. How do you determine the correct range for this circuit? The answer is by knowing the capacity of the power supply. In this case is a 24V battery, so the range should be set higher than 24 volts, such as 50 volts. Next is to connect the probe. Quick question. How will you know where to place the red probe and the black probe? You need to know where the negative and positive sides of your power supply are connected. In this battery, the positive terminal is on this side, and the negative terminal is on that side. Make sure the red probe is connected to the positive terminal, otherwise, the multimeter could be damaged due to incorrect polarity. Now we can read the voltage on the display. The range is set to 50 volts, so each bar represents 1 volt. The first mark is 0 volts, followed by the next big bar at 5 volts, then 10 volts, and 15 volts. The bar just after 15 volts indicates 16 volts, since each bar corresponds to 1 volt. We can now proceed to bulb number 2. The range is still set to 50 volts, starting from 0 volts. The next marks are at 5 volts, 6 volts, 7 volts, 8 volts, and 9 volts, so the voltage across bulb 2 is 9 volts. Next is bulb number 3, with the same 50 volt range. Again, the marks show 0 volts, 5 volts, 6 volts, 7 volts, 8 volts, and 9 volts, so the voltage across bulb 3 is also 9 volts, the same as bulb 2. Let's consider another scenario. In this schematic circuit, the 3 resistors are connected in series, each with a different resistance. Measure the voltage drop across each resistor. First, set the multimeter to the DCV setting. This mode is used to measure the voltage in circuits powered by direct current sources, such as batteries. Once the multimeter is in DCV mode, select the appropriate range. In this case, since the power source is a 9-volt battery, setting the range to 10 volts is ideal. This range ensures that the full voltage of the battery can be measured without exceeding the limits of the multimeter, which could result in inaccurate readings or even damage to the device. Next, connect the probes to resistor 1, making sure to observe proper polarity. The red probe should be connected to the positive terminal, and the black probe to the negative terminal. Incorrect polarity could lead to incorrect readings or potential harm to the multimeter, especially in more sensitive circuits. Once the probes are connected, you're ready to read the voltage. With the range set to 10 volts, each small division or bar on the analog scale represents 0.2 volts. For instance, if the needle points just after the 5-volt mark. The value is 5 volts plus the additional 0.2 volts, giving a total of 5.2 volts. This reading is the voltage across resistor 1. Now, let's measure the voltage across resistor 2. With the range still set to 10 volts, the same principle applies. Each bar or division equals 0.2 volts. Starting from 0 volts, the needle moves through increments of 0.2 volts, 0.2, 0.4, 0.6, and finally 0.8 volts. This means the voltage across resistor 2 is 0.8 volts. Finally, let's measure the voltage across resistor 3. The needle might start at 2 volts, then move through increments of 0.2 volts. As it progresses, you'll see the needle pass 2.2, 2.4, 2.6, 2.8, and finally reach 3 volts. Therefore, the voltage across resistor 3 is 3 volts. This process demonstrates how to accurately measure and interpret DC voltage readings using an analog multimeter. It's crucial to select the correct voltage range before taking a measurement, as this affects the precision and safety of the reading. Additionally, ensuring that the probes are properly connected to the correct terminals, positive to positive, negative to negative, is essential for obtaining accurate results and preventing potential damage to the multimeter. Following these steps will allow you to confidently measure voltages in various circuits, helping you diagnose issues or confirm proper operation. Next, let's discuss measuring and reading AC voltage. The process is quite similar to measuring DC voltage, with a few key differences. Firstly, you need to adjust the position of the multimeter's range knob. Instead of using the DCV mode, switch to the ACV mode. This mode is typically indicated by a symbol of a sine wave, which represents the alternating nature of AC voltage. Make sure you select the appropriate range based on the expected voltage in the circuit. Secondly, unlike DC voltage, AC voltage does not have polarity. This means there is no positive or negative terminal in the context of measuring AC voltage. As a result, you can connect the probes in either orientation. There is no need to worry about which probe is connected to which terminal. The red probe and black probe can be placed in either position without affecting the measurement accuracy. Quick question. What happens if we place the probes on a single wire or line? If you place the probes of an analog multimeter on the same line in a circuit while trying to measure AC or DC voltage, the multimeter will not display a proper reading. For accurate voltage measurements, the multimeter needs to measure the potential difference between 2 points. Placing both probes on the same line means there is no potential difference, so the needle on the analog multimeter will likely remain at 0 or very close to it. Additionally, incorrect probe placement could result in inaccurate or misleading readings, and in some cases, it might even damage the multimeter if the voltage is too high for the selected range. Now, let's begin measuring AC voltage. First, set the multimeter to the AC voltage mode. This is typically indicated by a symbol of a sine wave on the multimeter. Next, select the appropriate range. It's a good practice to start with a range higher than the voltage you expect to measure. For instance, if you're measuring a 220-volt outlet, start with the 250-volt range. This approach ensures that the multimeter can accurately measure the voltage without overloading or damaging the device. Next, connect the probes. Safety tips. Wear protective gear. Always wear rubber gloves and safety glasses when measuring AC voltage to protect yourself from potential electrical hazards. Be cautious of live circuits. When working with live circuits, be extra careful not to accidentally touch any conductive parts, as AC voltage can cause severe injury or death. Double-check the multimeter settings. Make sure the multimeter is set to measure AC voltage and that the range is appropriate for the expected voltage level. Attach the red probe to one terminal and the black probe to the other terminal. With the range set to 250 volts, each bar on the scale represents 5 volts. The readings are as follows: 200 volts, 205 volts, 210 volts, 215 volts, 220 volts, 225 volts, 230 volts, and 235 volts. Why is the reading 235 volts when it is a 220V outlet? Household voltage can vary slightly due to fluctuations in the power supply or differences in how the power company distributes electricity. Although the outlet is nominally rated at 220 volts, it's common for the actual voltage to be a bit higher, typically between 230 and 240 volts. This variation is generally within acceptable limits. In conclusion, mastering the use of an analog multimeter for measuring both DC and AC voltage is a fundamental skill in electronics. By understanding the difference between DC and AC measurements, and by correctly setting the range and connecting the probes, you ensure accurate and reliable readings. For DC voltage, remember to select the DCV mode, choose an appropriate range, and be mindful of polarity when connecting the probes. For AC voltage, switch to the ACV mode and connect the probes without worrying about polarity, as AC voltage does not have a defined positive or negative terminal. Always ensure that your multimeter is properly set and that the probes are correctly connected to obtain precise readings and maintain the integrity of your measurement tools. By following these steps and practices, you can effectively measure and interpret voltage in various circuits, which is essential for troubleshooting and understanding electrical systems. Accurate measurements are crucial for diagnosing issues, verifying circuit operation, and ensuring the safety and functionality of your electronic projects. Thank you for watching.